Okay, so this talk is about change detection Angular 2. And I want to show you today how change detection Angular 2 works, why it's super fast, how we can make it even faster. And I want to really so that you get an idea of what's going on when we build Angular 2 applications. Do we have any people in this room who already built some Angular 2 things? Yes, that's cool. I have Angular 2 stickers. You might want to find me after the talk. Alrighty, so this talk is also a little bit technical. If there are some things that you don't really understand the first time, it's totally fine. It took me a long time to actually get that stuff. There is an article here on the slide deck and a link. I'm going to share the slides after the talk, and then you can actually read everything I'm going to talk about today. And we start off with change detection. What is change detection? So when we build applications, web applications specifically, we usually have some sort of model, right? So we when we build JavaScript applications, we have data structures numbers and strings and arrays and that kind of stuff. And what we want to do is we want to take these that data that represents our model. We want to take that stuff and make that usable to the user in some sort of UI. And in web applications, this is where the DOM comes into play, right? This is the thing that renders what the user sees in the browser. And so if we think about it, it's actually not a super, super hard thing to do. It's some sort of function, actually. We take some input, which is the model, the application state, and we make it visible with DOM. So we input a model, and we output DOM. That's pretty much what we do when we render some stuff, right? And so the things in the DOM, these might end up as paragraphs or links or buttons or whatever you build in your application. And while this seems to be quite trivial, there's one thing that makes it a bit tricky, and that is tracking changes over time, right? So let's say there is some sort of change that has happened, and we're going to explore in a second what a change actually means. But let's say we have, users are interacting with our interface. They click some buttons, AJAX requests are performed, or whatever, some sort of change is happening. And that change is somewhere in our application state. We see it here in the model. It's down there. But what we actually want to do then is we want to update that specific DOM node in the DOM. And so the task that we have here is we need to find out which DOM node needs to be updated. And so that means we need to operate with the DOM. And the tricky part here is that we want to keep these operations as low as possible because they're usually very expensive. And so we need a way to basically find out what has changed and where do we need to update things in our apps. And there are different ways to do that, right? If you think of classic websites, you have an HTTP request going to the server, a response with an HTML site. If you click a button, you do another request, you get a new site back. That's one thing, one way to handle it. If you think of RuhrJS, they have virtual DOM to solve that problem. And there are really different ways to do that. In Angular 1, you have the dirty checking digest cycle thing. But after all, we always try to do the same thing. We want to project the data of our application to the user. And if you want to read about change and its detection in different JavaScript frameworks, there's an article here written by Tero. He's a super nice guy, and he gives a nice overview about how different JavaScript frameworks solve these problems. And actually, my graphics here are kind of inspired by that article. So now that we know what kind of problem we want to solve, let's talk about what actually causes change, the thing that introduces the problem. So let's start off with an Angular 2 template. So for those who haven't done any Angular 2 stuff yet, let me see if I can actually, this is really super bright. I'm sorry for this. I cannot turn off the sun. Probably I can not even, oh, that doesn't help either. Okay. Actually, if you go in your browser and then you search for Angular 2 change detection explained, you can probably find these slides and then follow them. So what we see here is like a simple Angular 2 component template. Obviously, we have a headline here with like 2 expressions, first name, last name, and they're obviously getting like, some sort of concrete value at some point in time, at runtime, right? So these are expressions, they evaluate to some sort of string. And then there's a button, which has an event handler registered for the click event, and whenever we click that button, there is a function or a statement change name that's going to be executed. And this parentheses syntax that we have here with the click event, this is just Angular 2's declarative way of binding to any event, right? Any DOM element, event on that element. In this case, we're binding to the click event. Okay, let's take a look at the component that is responsible for that template. It looks like this. So it's really like that's like a very simple Angular 2 component, right? After all, it's really just a class, ES 2015 class. We see like this decorator up here. Actually, we put some information in there. I left that out for now so that we have more room on the slides. But an Angular 2 component is really just an ES 2015 class, right? There is no real Angular machinery going on there. That's just like, the standard. It's a class. And we see the properties here, first name, last name, and there's also this function, change name, which obviously changes the first name and the last name. So whenever the button is clicked in our template, that function is going to be executed, we change the application state, right? This is when a change has happened. Here's another example of a context application which basically has like a list of contacts which is initially empty, but when this component is initialized, we fetch the contact data from a remote server, right, using HTTP. So, we do this HTTP call, we subscribe to that call, and once we get the data, we assign it to the contacts property, and the moment we get that data, again, the application state has changed, because now it's not an empty collection of contacts anymore, it's an actual collection with data. So if we think about it, after all, there are just 3 different things that can really change application state in our web applications, and that's events, click, submit, and all the other events that we know. There's XHR, so AJAX requests. Whenever we send data to a server or request data from a server, this is also the moment when something can change. And then there's things like timers, because JavaScript, right? We have set timeout and set intervals and these kind of things. So this is when we basically kind of register some sort of callbacks that are executed once they return. And that's the moment when Angular has to perform change detection, to find out, first, did something change, and if so, what and where, right? And also, all these 3 things, they have one thing in common, which is that they're asynchronous. And that's a very interesting observation, because that basically means that whenever an asynchronous operation happens, change detection needs to be performed. That's the only moment when something can change in our applications in the web, right? So now the interesting question is here, who notifies Angular? Who tells Angular, hey, listen, there's some asynchronous operation going on, and you now need to perform change detection? Someone has to tell Angular, you have to do that. And because it's Angular, obviously, there has to be some sort of magic, right? Well, Angular embraces a feature called zones. And zones is actually a language feature that is in Dart, the Dart language. And they kind of, they backported the zones language feature as a JavaScript feature, to JavaScript. And so what zones do, they allow us to inform the framework, or they inform the framework when something has happened. We're going to take a look at that in a second, what that looks like. But let's understand JavaScript first. We need to get a better idea of what that means, when something asynchronous happens. So in the browser, we have this thing called the event loop, and I know this is really hard to see, but I'm going to explain everything that's happening right here, right? So we see on the left-hand side, there's a code snippet, which you probably cannot read. All you see there is a foo function which does something. Then we have a set timeout function with a callback, and then a bar function that also does something. And then we see this thing called the stack, and the stack is the thing that basically keeps track of where we are in our program, right? This is what's going on in the browser. And whenever we execute code, that code is executed on the stack, one code at a time. That's because JavaScript is single-threaded. And then we have this thing called web APIs that we have available in the browser. This is basically all APIs that are not part of the JavaScript language. It's like set timeout and the DOM APIs. If you do Node.js, then you have like some sort of, I don't know, C++ APIs or whatever. And then there's this thing called the task queue and the event loop. And so what happens when we execute that code is basically the code itself, like the script already, right? That the browser fetches and parses, and then it's already a so-called main function, right? This is how the VM kind of treats it. And then it kind of sees all the function definitions, and once that is done, it executes the code. And what we see here is that foo is going to be executed, so that's kind of put on the stack. And when foo returns, it pops off the stack, right? And then the next code is executed, which is the set timeout call, right? And the set timeout call has this callback registered, right? Or it registers a callback. And so what happens here is that this callback ends up in the web APIs. This is where this thing kind of hangs around until it's called at some point. And we see in a second when it's called. The set timeout here is registered with 0 milliseconds. So you might think that this is going to be executed immediately, which is not really the case. However, set timeout is executed and returns, and then we have bar, and then bar is executed and returns. Boom, the program is done, right? That's the synchronous part of the code. That's what happens when we execute JavaScript in the browser. So again, we have this callback flying around here, and we can't just randomly at some point execute that callback, right? This is like web APIs can't just call that thing because maybe it changes some DOM or whatever. So we need to have some mechanism to deal with these kind of asynchronous operations. And that's where the task queue and the event loop comes into play. So whenever the stack is done, the web APIs basically push whatever is registered there to the task queue as the next task. So here we have this callback which is registered with a timer, right? The timer was set to 0, so the timer is done. And at this point, the callback is going to be pushed to the task queue. And then we have this event loop going on there, which is like just a little loop that kind of checks every time if there's some task in the task queue and if the call stack is empty. If that's the case, then the next task is put on the call stack and then executed and done. Right? This is what people also call the next tick. That's why even if this code is like registered, like the set timeout is registered with like 0 milliseconds, still this code is going to be executed after the synchronous code is done. Okay, and this also applies to things like click event handlers and these kind of things, like everything that is asynchronous. And what I've talked about like 3 minutes is like basically a rip-off of Philip Roberts' talk, What the Heck is the Event Loop anyways? And he can explain it way, way better, and you should definitely check it out if you want to dive deeper into that kind of stuff. But why is that important? Like, why did I talk about that? So I mentioned zones as a feature that notifies Angular that it has to perform change detection. So what zones do, they basically perform some sort of task whenever an operation is entered or exited. So if we do a set timeout, we can execute code before the set timeout call is done and after the set timeout call is done. So what does that mean? Let's take a look at that code again, right? So we have the foo function, we have set timeout, we have bar. We can run that code in a zone just like that. So what we use here is zones.js. That's the library that has been backported as the language feature from Dart. And what we do here is we simply run our code as a task in a zone. If we execute it like that, there's basically no difference at all, right? There's nothing special happening. What we don't see here is that things like set timeout and all the other asynchronous APIs are monkey patched. Zones monkey patch those. And basically, why that is because it wraps hooks around these native calls. So because we are running this code in a zone, and because a zone knows when to execute a task, we can actually hook into these moments and do some certain things whenever a task is executed. So while this code is just executing normally, we can say, hey, we want to log whenever a task is done. So we can fork this zone, and whenever we fork a zone, we can define onEnter and onLeave callbacks. And those are the things, the hooks that are executed before and after a task. And a task is an asynchronous operation or the code itself that is in the run block, right? So everything that is asynchronous is a task. And so basically what that means is as soon as we run code in a zone, we can be notified when a task is done, like setTimeout. And Angular does exactly that. It has its own zone, right? It forks this root zone, calls it ngZone, and adds some nice APIs on top based on observables. So we have things like onMicroTaskEmpty, onError, and some other things. But after all, it really boils down to the same thing, right? We have our code executed in a zone, which doesn't affect the code at all, but it allows us to hook into certain events. And so basically, what happens behind the scenes is this. So this is like a very simplified version of what happens in Angular. Whenever like some sort of asynchronous operation is done, Angular executes a function called tick. So what we do here is Angular basically subscribes to its own zone, the ngZone, and ngZone notifies Angular, hey, this setTimeout call is done, or hey, this click event handler has been executed. And then Angular executes tick. And tick is really just a function that iterates over all change detectors of the app and performs change detection. That's like a very simple version of what's going on there. Nice sound. So who has done some Angular 1 in this room? AngularJS. So you all know this scope.$apply thing, right? This is the reason why you don't need scope.$apply anymore. Because zones notify the framework that some change might have happened. Okay, if you want to read more about zones, there are 2 articles on our blog about zones and about zones in Angular 2 specifically. But now that we know what actually notifies the framework when a change has happened, or if like something could have happened, we now want to understand how change detection is performed. So change detection. First of all, in Angular 2, an application is really like a component tree, right? So you always have a tree of components. You have a root component, and then you have some child components, and so on and so forth. The first thing to realize in Angular 2 is that every component has its own change detector. So there's not just a single mechanism for the whole thing, like the dirty checking in Angular 1. It's really that every component has its own change detector that knows how to detect changes on that particular component. And so basically what happens is when we have this application here with like some sort of components, and this could be like hundreds or thousands of components, some event is happening inside that application, right? And we know what the event is, right? That's like a user clicks a button or an HTTP request returns or whatever. An event is happening, the zone is, the zone notifies the framework, hey, this task here is done, so change detection kicks in. And change detection is always performed from top to bottom. So it starts at the root component, and then it goes all the way down for every single component, every single time. And that's actually nice, because what we see here is since the change detection is performed always from top to bottom, the data flow is also from top to bottom, right? It's unidirectional. If you're into React, then this is probably, familiar to you because it's pretty much the same thing. Data flows from top to bottom. And that makes it way more predictable because there are no cycles. It's not that like some sort of directive can update a model or anything, right? It's always from top to bottom. We know where the data comes from. If we have a child component and we see that it gets some data, we always know that it gets the data from the parent component. Another nice thing in Angular 2 is that this change detection, task is done after a single pass. So there's not a cycle anymore. It's really just one pass and it's done. So that's already way better. But again, change detection is always performed in the same order from top to bottom. Keep that in mind. Okay, so how fast is it? Viktor Safkin, he's the core developer of the Angular team. He has created the change detection mechanism in Angular 2, and he says it's usually very fast, which of course is like, well, some statement, right? But Angular 2's change detection is really, really fast, and that's because Angular 2 generates VM-friendly code behind the scenes for us. So basically what that means is instead of having some sort of change detection mechanism that tries to find out all the changes for every component, we have change detectors for every component, and every change detector knows exactly what kind of things can change and in what way. And that makes the code monomorphic. So it basically means that Angular creates change detector classes for every component at runtime in a way that VMs can optimize that code. So it basically generates code that is, the best performant code that you can possibly write manually if you would write it manually. It's just that Angular does it for you at runtime. And that's why it can perform hundreds of thousands of checks in a couple of milliseconds, which is pretty amazing. Of course, this doesn't work if you have polymorphism going on, which is the case in Angular 1, right? You have like this single mechanism that tries to find out changes for like different things. There's an article called What's Up with Monomorphism if you want to read into that. It's a bit low level, but it's super interesting. So here are some facts about Angular 2's change detection. First of all, the change detection graph is a tree, right? So it's not you don't have cycles anymore. It's really like top down, it's just a tree. It's way more predictable. We always know where the data comes from. It gets stable after a single pass, and Angular generates VM-friendly code for us at runtime, which allows VMs to optimize the code and makes it as fast as possible. And that's really fast and really cool, but we can still do even better. We can make Angular's change detection smarter if we tell Angular some certain things about our code that we know. For example, we can tell Angular, hey, we do have this component tree right here, but we know that at this particular event, that part of the component tree actually doesn't need to be checked because we know that there's no change happening, right? We as a developer, we can actually tell Angular, hey, this part you don't need to update. And in order to make that happen, we need to get some certain guarantees about how our application works and how we can tell Angular, hey, you don't need to update that subtree because, well, we know about it. And we have basically two different ways to deal with that, and those are immutable data structures and observables. I'm going to talk about immutable data structures for a second, but first of all, I'm going to talk about mutable objects so that everyone knows what we're talking about. So mutable objects basically means that we have objects that can change, right? And that's the default in JavaScript. You can basically change every object, except for some things like a string you cannot really change. But you can you can have an object with a property and it's a string foo or whatever. You can change that property if you want. Immutability means exactly the opposite. But let's take a look at this code first. So we have a component here called vCard_app. It uses a child component called vCard. And vCard gets its data from the vCard_app. And the data is simply an object with a name and an email property, right? Simple JavaScript going on here, nothing special. And then there's this change data method. And whenever that is executed, we change the name property of our data. So let's take a look at what that looks like when we visualize that. So we have the vCard_app component and the vCard component as a child component. And we know that the vCard_app passes data to the child component. And basically what it does is it checks, okay, when an event happens, first of all, the change detection is performed from top to bottom again. The moment change detection is performed, the name property changes because we know, we saw the function that changes the name property, right? So the data object has changed. vCard component now checks if the old data that it had is the same as the new data. And technically it is, because it's exactly the same reference. And that's why Angular still has to perform change detection, because maybe a property has changed, which is the case, right? We changed the name property, but the object itself hasn't changed. And that's why Angular has to be conservative about checking components every single time. It has to check all components every single time when things are mutable, because, well, we don't know. Maybe something has changed. So, but still, we can tell Angular that it doesn't have to check some certain things when we know that nothing has changed. And we can tell Angular about that with immutable data structures. And again, immutable data structures are really just objects that cannot change. In JavaScript, we have mutability going on, so what we need is some sort of API that create immutable objects for us, right? You can use whatever you want. You can use, immutable JS, or I think there's something called Kefi or something. So those are really just like some APIs that create objects for us. They give you new references whenever you try to do a change. So here we have some API for immutables, .create, which creates some immutable object. It's just an object with a name property. And in order to change the name property on that object, we need to use the set method. That's like something I made up, right? You need to use some sort of API for that. And what you get here is a new reference. You get a new object. You don't get the same object with a different property value. You get a new object, which is really a new reference. So if you compare these two objects, they're not the same. So how can we take advantage of that guarantee? Well, so making a change always results in a new reference when we use immutable data structures. And if we use immutable data structures, we can actually reduce the number of checks. Because we can tell Angular, hey, this thing here is immutable, and if the reference hasn't changed, then you don't need to check that tree. And here's what that looks like. So here we have the vcard component, the thing that gets the data from the parent component. And we can see that it only depends on its inputs, which is the data that we pass to that component. Right? An object that has a name and an email property. Now, we can add some information to the component decorator, which is the change detection strategy. If we set it to onpush, we basically tell Angular, hey, do not perform change detection on this thing here unless its input properties have changed. And we now know a change means a new reference in case we use immutable data structures. So if we go through that again, we have the vcard app. It has the vdata, name and email. And now an event happens. Change detection kicks in. This time we do not change that name property. So that object is kind of immutable. It's immutable in the sense that it just hasn't changed, right? It's just the same thing. But since vcard component is set to onpush, it checks, if the data that it gets is the new one as the same one as the old one. And it turns out it's not. It is the same, sorry. It's the same, exact same object because it's exactly the same reference. And then Angular knows, all right, I don't need to perform change detection on that subtree here. So this is just two components, but again, think about a bigger application with like way more components. Here's the same component tree that we had before. The second one here is set to onpush. And now when change detection is performed and the input property of that component hasn't changed, then the subtree on the left-hand side is skipped, which makes change detection even faster because it's always faster than checking every component every single time. And I have a demo on that one. Where's my mouse? There. So here we see a component tree with 17 components, and this one up here is set to onpush. And if I refresh the page, we see that all components are turning green, which means change detection is performed for all components. And that's because Angular has to do that when it bootstraps an application for all components. That's the initial state, right? But now at runtime, if I trigger change detection due to some event, I click that button right here, we see that the second, like the left-hand side is skipped, right? It doesn't perform change detection on that part. Again, that's way faster than the already fast change detection. Another thing that we can use is observables. I don't have the time to dive into observables here, but to give you like some picture of it, an observable object basically can emit some event, and we can subscribe to an observable to listen to that event and then do something and react to it. So how do observables help in that case? Like, how do they give us some guarantee that something has changed or not? When we deal with observables, there is not like a new reference that we get every single time when something has changed. Instead, it emits events, and we can subscribe to them, right? So what we see here is a cart batch component. You can basically think of an e-commerce application where you have a shopping cart on the top right corner with like a little badge that shows a number of how many items are in the shopping cart, right? And so like whenever a user puts some product into the shopping cart, that number increases. And basically what we see here is we have this add item stream as an input property. The component is set to onPush. And whenever that item stream emits, it's an observable, we can subscribe to it. We increase the counter that we have, which is initially on 0. So now if you would run that, here we have our component tree. Everything is set to onPush, everything. An event happens, like the observable emits an event. Change detection is performed, but it stops propagation immediately because everything is set to onPush and no input properties have changed. So we need a way to tell Angular, hey, even though everything is set to onPush, we know that this observable has emitted an event, so we need to perform change detection. And we can do that by simply injecting a change detector ref to our component. And whenever we know that at some particular point in time we need to check something, we can say, Angular, please mark the path from root to that component for check for the next change detection task. And that's what we do here. When we subscribe to that thing and whenever it emits an event, we mark the path to that component to be checked. And so basically what happens is this. Again, the same component tree, everything is set to onPush. An event happens. This path here is basically opened up for change detection because we marked it for check. And then change detection kicks in, only for that path. Again, which is also way faster than checking every component every single time. And after that, it restores the original state. So everything is super fast again. I have another demo on that one. Here. Up here. So same component tree, everything is set to onPush, and component 17 down here. This one has an observable that it subscribes to. And if I click this button up here, I can cause this observable to emit an event. And even though everything is set to onPush, the path to that component is checked, right? Do it again. And if I trigger change detection, like a general one, like a normal click event, and not through that observable, it doesn't check everything. Again, that's way faster than checking every component every single time. And you're not forced to use either or the other like data structures. You can use both. You can mix and match them. You can just use immutables. You can use observables, or none of them if you want. Angular is pretty agnostic when it comes to these kind of things. But it allows you to make change detection even faster if you need it. OK, I think that's all I got. I don't even know how much time I have left. So thank you.